So let's talk about what it really means to be an engineer today. It's more than just crunching numbers, right? It's about building things that actually matter. We're going to dive into the Mechanical and Aerospace Engineering Department at George Washington University, where their entire focus is on engineering for a better world.
So what does that actually look like in practice? Well, at GW, they have this core idea they call the engineering and approach. You can see it right here in this quote from the department chair. The whole point is that engineering doesn't exist in a vacuum. It's a tool, a bridge that connects to, well, everything else. Business, law, policy, health, you name it. They're not just training engineers. They're creating problem solvers who can work across any field.
Okay, so how do they actually build an engineer like that? It all starts, of course, with a super strong academic foundation.
For students who are really ready to hit the ground running, check this out. They have an accelerated program where you can get both your bachelor's and your master's degree in just 5 years. It's pretty straightforward. You keep your GPA up, apply in your junior year, and then you start taking grad-level courses as a senior. This is a huge head start. You get into the workforce with an advanced degree, and you save a whole year of time and tuition. It's a real game changer. But it's not just about going fast, it's about finding your focus. This is where you can really see that engineering and idea come to life. The undergrads program lets you build your own path. Sure, you've got the classic options like aerospace and robotics, but you can also specialize in things like patent law, or even do a pre-med track. You get to build a degree that's tailored exactly to what you're passionate about.
All right, so you've got the world-class education. Now for the fun part. Let's look at where the theory gets its hands dirty, where all that knowledge turns into real, actual innovation. This quote from the GW Baja team co-captain just says it all, doesn't it? Student project teams are a massive part of the experience here. These students are designing and building incredible things, like an entire off-road race car completely from scratch. I mean, we're talking about some students spending 40 hours a week in the machine shop. In that kind of environment, you don't just learn to solve problems. You build this incredible bond with your team.
And the results? They really do speak for themselves. Take the GW Rocket team. At a huge international competition, the Spaceport America Cup, they build an 18-foot dual-stage rocket. And get this, out of all the teams there, theirs was the only one whose second stage actually ignited successfully. That's not a class project. That's a major win on a global stage. So what happens when you have that kind of hands-on success? It leads to some absolutely incredible career opportunities. We're talking about students landing internships that are frankly mind-blowing. Ariana Haven was at NASA, designing systems for hypersonic wind tunnels. We're talking Mach 6 and Mach 10. Connor Gillespie and Andrew Adzenga were at Tesla. And Allegra Farrar? She was at Northrop Grumman, doing data analysis for the James Webb Space Telescope. These are not just coffee-run internships, this is real work on the most cutting-edge projects in the world. And the experience goes way beyond the workshop. We're talking about a truly global perspective. Students can study abroad in places like Australia or South Korea. They're competing in high-stakes ethics competitions sponsored by giants like Lockheed Martin. And for their final capstone projects, they're tackling huge real-world problems, like building an autonomous firefighting drone, all while they're networking with their future employers, companies like Blue Origin and Raytheon. Okay, so beyond the student projects, the faculty and students are also teaming up on research that is seriously pushing the frontiers of science. Let's look at a few projects that are having a massive real-world impact. Let's start with a question that could literally change millions of lives. What if you could create a cancer treatment that was smart enough to only attack the tumor, leaving healthy cells alone? This isn't just a hypothetical. It's the mission behind some of the most important research happening at GW right now.
One of the potential answers, microbubbles. In Professor Kazak Sakar's lab, they're engineering these tiny little gas bodies. Each one is about the size of a single red blood cell. You can think of them like tiny, programmable delivery drones for medicine. The goal is to load them up with drugs and send them directly to a tumor. This could totally revolutionize treatments like chemo, making them way more effective and so much less toxic.
And if that wasn't incredible enough, get this. Professor Michael Kadar has pioneered a completely different approach using something called cold plasma. It's basically an ionized gas that he's figured out how to use to selectively kill cancer cells without damaging any of the healthy tissue around them.
And this isn't just a cool idea in a lab. This technology is so advanced, it's already been used in an FDA clinical trial. It's just amazing.
All right, next up, I'm just going to put a number on the screen. 360%. So, what in the world is that about? That number represents a massive leap forward in sustainable energy. You know all that heat that just pours out of our cars, our factories, our power plants? Most of it is just wasted. Well, Professor Sonia LeBlanc's lab is changing that. They used 3D printing to create this amazing new hourglass-shaped device that's way better at capturing that waste heat and turning it back into electricity. How much better? 360% more efficient. Just imagine how much energy we could recapture.
And the research is also looking to the future of how we travel. It sounds like science fiction, but autonomous aircraft and air taxis are coming. And that brings up a huge new question. How do you stop them from being hacked? Well, Professor Peng Wei is leading a NASA-funded project to do exactly that, to build the AI and security systems to protect the next generation of flight.
So you learn in the classroom, you build in the workshop, you innovate in the lab. Then what? Where does this whole journey lead? Let's take a look at how GW launches these incredible futures out into the world.
This quote from a recent grad, Brendan Humphrey, really says it all. He knew he wanted to be somewhere he could make a real difference, a place where his contribution really mattered. He turned his passion for design into a job at a cool wellness startup called Plunge. And in a perfect sign of the times, you know how he got the job? He connected with them on LinkedIn and made his case. That's modern initiative right there. And Brendan's story is definitely not a one-off. It's the norm. GW engineers are in super high demand everywhere. They're landing at the biggest names in the industry: Boeing, Tesla, Lockheed Martin. They're going into crucial government agencies like the Naval Research Lab. They're joining innovative startups, and they're getting into the top PhD programs in the world, including at places like MIT. So when you put it all together, from life-saving medical devices to sustainable energy to the future of flight, what you're really seeing is a blueprint for engineering what's next. It's about giving students not just the technical skills, but the mindset to connect, to innovate, and to lead. We've seen how they do it. We've seen why it matters. So really, the only question left is the one right here on your screen. What part of the future will you build?